Hey YouTube land, I'm Watson, and you're watching Cryptic Creations, where we bring you the not-so-obvious. Today is June 2nd, 2019, and this is my 97th YouTube video. Getting close to 100. And today we want to talk about, we're going to continue with where I had picked up in videos 95 and 96 to actually do some tracking of human development by splitting it into categories. And so here we see the category of mobility, or just otherwise like locomotion, and we're combining biological with technological. And we're going to come right back to this because we want to clarify something real quick, and that is that whenever we talk about, or what we're talking about with the graph, with graphing development over time, with those that we were just showing, like key points in locomotion, you know, like legs or fins, feathers, and membrane wings, etc. We're going to get back to that, but it's like that graph is basically just time versus time, because it's like it's key events which are in units of time measured over time, so it ends up being just a linear graph. And the like this. And so I know that Kurzweil's graph in his book, The Singularity is Near, yeah, I guess technically this would be a linear plot if you're just counting from, if you're just going from the x scale, but on the y it's clearly a log scale, which gives it this characteristic nosedive appearance. But if you just do linear versus linear time, and if this first point here is 4 billion years ago, or 3.7, 3.8, just under a billion years whenever we first get the first microbes, then it's just a reflection of itself. It's that far back from the present and that far up above itself there. So but where the logistic curvature comes in is right here, because, well, remember what we were just looking at, like those dots were getting closer and closer together as it was nosediving. That was linear versus linear for key events. And then if you just hexagram or bin, or otherwise bin into discrete units of time, you will then construct at least on the half of it, at least on this half of it, because that's like projecting into the future on the right hand side, but it's essentially showing a Gaussian distribution curve, and that's where that's where it fits in with the logistic development, because the logistic curve on the y is total development, so you would be taking all of those coordinate points, and then however many there were, that would constitute 100% at the top, the y equals 1. And then as you approach the inflection point and the y-axis, that's where you're hitting the max in the rate curve. So that's just basically it. And then here we're looking at the Easter egg analogy, and how and we'll get right back around to this as well later on in the video, about how like if you have a set amount and you have of developments to be made per category, then like you have you have fewer developments to be made, and the ones that are left to be made are harder to to find. And whenever you think about an Easter egg hunt, the rate of egg acquisition increases and then decreases as you approach the maximum. And again, in nature, there has to be, if there is a maximum, then this is the way that we would assume that you would approach that maximum. If there was no maximum number of things to be learned, structural wise, like law wise, we're not talking about like position of everything, but I guess it does eventually get sort of a gray area as far as like what constitutes a new piece of knowledge. But that's what we basically just wanted to clarify there with the graph, because it was a little bit ambiguous in videos 95 and 96, only from the perspective of not having seen my video, my prerequisite video to this subject, which is the singularity is not near. And again, this is eschatology revived. And so what we would be, I'm sort of just keeping you updated in real time. What we're doing now, what we're going to be doing is, because see, this is a rough draft list of all of the biological and technological developments in transportation or otherwise mobility, and we're going to have to research each one of these. And this is a rough draft. If I just said that, I'm sorry, but it's a rough draft, and we need to research each one of these categories or subcategories, I would say, and get the best estimate of when these came about. We have, I'm probably going to have to do a list of complications to doing this. One of the main ones that just came into my mind is the fact that you have, on the technological side, you're going to have people coming up with the same ideas at slightly different times in different places. So, I don't know, we're probably going to have to like take the average or something in those cases. But, so yeah, we're going to have another list which is going to be comprised of the complications, the difficulties, which we want to be transparent about. And then we have another list from which this one comes from, which will be a semi-exhaustive list of all of the categories of development. Because again, if you watched video 96, you understand that I'm proposing to subdivide human development into categories so that we can see whether or not it's plausible that things are speeding up or not. And I had already seen yesterday as I was brainstorming that it's going to be difficult to fully map or even come close to fully mapping some of these subcategories, like the developments in medicine, like life-saving procedures, for instance. Like, that would require a lot of research. just think about it, all the developments, and because that's going to be some of the information. That's like really cutting edge information. Like, you have to get into peer-reviewed medical journals and figuring out like all this stuff. And then there's the question of whether like discovered is sufficient or whether it has to be applied. If it's like just something that was discovered in a lab, or are we waiting for it to pass the FDA standards, etc. But getting back on track here, so what the process here again is going to be for the next week or 2, maybe even 3 weeks, to get this all crunched down into data that we can, into a nice pretty picture that we can talk about at the end, is going to be researching all these categories, thinking about other all of these subcategories or developments in mobility, locomotion, or otherwise transportation, and seeing if we've left anything out, finding the best fit for time, putting them all in chronological order, and then getting the deltas between successive elements. Then we can use the vertical, not the vertical line test, the path rule from discrete linear difference function, DLDF, which is semi-functional. It's really just a procedure, but it functionalizes a discrete sequence. In this case, the application is to have events chronologically ordered in time, and then you construct a graph. And I guess we would be looking for what the path rule shows or will show for a series of events that are getting closer together and then farther apart later on, will be depicted and characterized by a general decrease and then an increase. That's what we see here. Sorry, that was like really choppy, rambly, but I hope you got the picture. And again, like it's fine. Like it's fine if I talk all choppy and disconjointed and however you want to say it, because like I just have come to feel that authenticity is better than trying to be scripted, because being scripted is somewhat fake. Being unscripted is more authentic. It's less organized, but it's more entertaining and more authentic, and people appreciate it more, I feel. And so that's pretty much where we're at for now. I'm going to let y'all go. Stay tuned for the next video. This is Watson Williams for Cryptic Creations, signing out. We bring you the not so obvious, and you love it.